This course in quantitative methods is the precursor to financial econometrics. Now, econometrics is all about using regression analysis to find relationships between various different variables in the financial markets. Now, this is an introduction to how econometrics works. It's basically running a regression, finding a line of best fit. Now, this here, we've got here some made-up data. X is 1, 3, 6 and 8. Y is 10, 9, 7 and 8. Okay, so here's a scatter diagram. And what we actually want to do is we want to stick a line through there and find the line that makes the that fits the data best. Now, if you have a look at this on the regression example, these are exactly the same numbers. Okay, these are exactly the same numbers, values of X, Y. Now, what we've done is, I might actually change beta 0 is the intercept term. This is a standard equation. And beta 1 is the slope. Now, what I've got here, y hat, is the predicted value of y using a standard equation. So if I look here, that's my regression equation. Okay, so we're saying y, there's an intercept, it's a linear equation, there's a slope. And we note that it's not necessarily going to capture everything because, so we add in an error term called ui. Now, if I look at this, those predicted values, if you look at the equation and follow it through, they're the predicted values of y based upon the intercept and the slope, where the intercept and the slope is 1. Now, and you can see the straight line here is my line of best fit. The curvy line here is the actual data. What I've got here is the difference between the actual and the predicted, and then again what I've done over here is I've eventually worked out the difference between the two. E is the error, the actual value of y minus the predicted value y hat, and then I square them because of course they're going to be positives and negatives. Now what I want to do is I want to find the values of the intercept and the slope that make the sum of the squared errors as small as possible, because that is by definition the line of best fit. Now if I look at that, you can see that my line is not fitting very well. This has a negative slope, my fitted line has a positive slope. So I could muck around and try that. Now I reckon it looks like I should have an intercept term up here of about 10 or 11, so I'll put that up here at about 10. Okay, but then obviously I need to have a negative slope, so that is that. Now notice that has increased my sum of the squared errors at the moment from 90 to 198, so I'm going backwards. But if I make this negative 1, instead of the sum of the squared errors being 90, it's now 50, so it's getting there. But we're still not very close. Now I could keep fooling around with this thing forever, but the easiest thing for me to do, of course, is to use the solver, which you are now all experts on. So I go to the solver here. The solver says set the objective function, which is this, to the minimum value by changing the values of in that thing there, which is the intercept and the slope. So let me do that. And if I click solve, and let's watch here. See, at the moment the sum of the squared errors is 50, and this is the relationship between my intercept and between my actual data and the slope. So I go solve, and lo and behold, it found a solution. Instead of the error, sum of the squared errors being 50, it's now 1.5. And look at the beautiful fit that we've got. Okay. Now that's what regression is all about. It's sample data and trying to find a line that fits it best, and then we can use the line for all sorts of important things in the future.